bisector theorem. So the isosceles triangle theorem basically states what we wrote up here as definitions. It states if two sides of a triangle are congruent, so if you've got two sides of a triangle that are congruent, then the opposite angles are congruent. Okay, we're using symbols. We've got the angle symbol, triangle symbol, congruent symbol. Oh, let me move that up for you. There you go. So what we're going to do is take the vocabulary we talked about up top and put it into words. It's called the isosceles triangle theorem. If two sides of a triangle are congruent, then the opposite angles are also congruent. That is the isosceles triangle theorem. And we've talked about that up at the top where all the vocab was, where all that vocabulary was. We just kind of put it into a sentence now, instead of it just being definitions. So let's start with the first part. Two sides of a triangle are congruent. What do we call the congruent sides in an isosceles triangle? What do we call the congruent sides of an isosceles triangle? The two that are equal. Look up here. Which ones are the two congruent sides? Look at your definitions. They're called the legs. Good job. So here, let's draw them. I'm going to match the color. So I used blue. So I'm going to use blue down here to be consistent. Two sides are congruent. Those are the legs. If the legs of the isosceles triangle are congruent, what do we call the two angles that are equal? So in the isosceles triangle, what are the two angles that are equal called? The two congruent angles. What's the vocab for that one? Yeah, base what? Base angles. Good job. So if we're focusing on these, the opposite angles are congruent. Those are base angles. Basically, what this is saying is if you can find, so if two sides of a triangle are congruent, then the opposite angles are equal. It's basically saying what we learned up there. We're just putting definition into a theorem. If you've got two equal sides, you have two equal angles. Down at the bottom is where we're going to talk about reflections and perpendicular bisectors. So everything we reviewed before is going to be down at the bottom. Okay? We're going to write it in words first. It's going to be a lot of words. But then we're going to draw a picture, and it'll be a little bit easier to understand. So the perpendicular bisector theorem for isosceles triangles, that's already a lot of words. Okay? The theorem says if a line bisects the vertex angle, if a line bisects the vertex angle of an isosceles triangle, so we're going to have an isosceles triangle. If a line bisects the vertex angle of an isosceles triangle, then the line is a perpendicular bisector of the base. So I'll give you a second to write that down. It's a lot of words, but we're going to draw a picture down at the bottom to make it a little bit easier. So the way I want you to draw it is about here. I want you to put a dot. Give yourself some space because we're going to be drawing a pretty big triangle. Then I want you to count down, let's say 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want you to put another dot. So we're making a segment that's 10 boxes long. Now, from the dot here, I want you to count 8 left and 8 right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay. So we counted 10 boxes down, and then from that point down at the bottom, we counted 8 to the left and 8 to the right. Now we're going to connect it using your protractor. So the way we're going to connect this is we're going to connect this top piece here. You're going to connect all the way across the bottom, and we're going to use that middle dot here in a second. And then you're going to connect here. What you've created is an isosceles triangle. And so we're just connecting our pieces. We want to be as accurate as possible. Then we're going to name it. The top dot we'll name A. Then bottom left is B, middle is C, bottom right is D. So we're going to use all 4 of those little dots. So let's assume that this isosceles triangle is sitting on the base. So BD is my base. What are the names of the legs for this isosceles triangle? What are the names of the 2 congruent sides? Okay, BA. So I'll put 1 bar. What's the other leg? DA. DA. Good job. Now you can name them AB and AD. Those are the exact same. Okay. So if those are the legs of my isosceles triangle, what letters represent the base angles? D and B. Good. Base angles. This one and this one. So see how we have a really big isosceles triangle? What we're going to do is put this theorem on this picture. So the theorem says if a line bisects the vertex angle. So which angle represents the vertex angle? We've already got our base angle, so which letter is my vertex angle? The vertex angle is the angle that doesn't equal any of the other ones. So what letter is my vertex angle? What's the only other angle on that picture that we haven't marked? Look at the picture. Which angle have we not marked? A. So that makes A my vertex angle. How many curves does A get if it's not equal to anything? 2. All right. So this first theorem says if a line bisects the vertex angle. So what does bisect mean? If I was to bisect a segment or an angle, what do I do to that? Good. Tabby says half. Okay. So what I'm going to do is draw a segment from A down to C. We are connecting our angle bisector. So that line cuts my angle in half. This line is a perpendicular bisector of this base. So which angle down here is my perpendicular angle? Which of my angles is 90? Where do I put my boxes? B and D already have curves on them. Which other angle looks like it's 90? Which one looks like? Yeah, good. Angle C. They get 90-degree boxes because they are perpendicular. So right here, when it says perpendicular, that means here and here get 90. Okay. What two segments are now equal to each other? If we have a bisector, this line has cut through the base. What two segments are now equal? Okay, give me two letters. B to where? B to C. And what segment is BC equal to? You're on the right track. BC is equal to, yeah, CD. Good job. So what it's done is it has split this isosceles triangle into two right triangles that are equal. You now have a complete right triangle here and a complete right triangle here. Okay. So let's trace them out. You've got a big one here. And we'll be doing some algebra problems that involve the isosceles triangle. But what you've done is you've created, instead of one big isosceles triangle, you've created two congruent right triangles. And we'll talk about congruency as well later on in this chapter. But congruent just means equal. They're the same. Copy, paste. How many degrees does this yellow triangle add up to? Let's review something. How many degrees, if I added up all these angles in the yellow triangle, how many degrees should they all add up to? How many degrees are in a triangle? 180. 180. Good job. What about the blue one? 182. Good, or 180 as well, not 2. So those two triangles are the same. They add up to equal 180 degrees apiece. Now let's talk about the reflection part. Let's say that angle B is 30 degrees, and I'm just making it up. What other angle in our picture, we can look at the whole isosceles triangle, what other angle is 30? Yeah, the other side. Good job. So angle D is also 30. You can kind of envision, like what we talked about with your reflections, this line, I can flip this triangle over. They can smush together. These two angles are going to be equal because I can flip this triangle over here. So let's do some math. How do I find this little angle right here? I'll mark it with this. How do I find this angle?
Well, you add 90 plus 30.
Okay, so if I add 90 plus 30 and subtract it from 180, what do I get? 60. Remember, each little triangle has to add up to 180 degrees. So, yes, good job. The other one is also 60. So isosceles triangles, they use a lot of what we've previously learned. Triangles add up to 180. You learned about reflections last year. You learned about perpendicular bisectors last year. So all this stuff with isosceles triangles, we're going to use it all again. Okay. So let's try some algebra. So all of you, does anyone need calculators? You can grab them. They're in the black bin. I have to use my white bin to dump my AC water in. All right, so on page 19, we're going to start with algebra. So number 1 has 2 different problems into it. It says, find the measure of the vertex angle of an isosceles triangle if the measure of each base angle is, and we're going to start with the first one, 80. These are how a lot of your problems are going to be. There will be word problems, okay? So I don't want you to be intimidated by all of those words. You just kind of have to find the vocab words and see what each of the vocab words mean. Okay? So what shape are we working with? Let's start there. Okay, a vertex angle, but let's think shape.
Triangle.
Okay, a triangle. What kind of triangle? Isosceles triangle. So at least right there, we know where to start to draw. So the hardest part about word problems is sometimes we don't know where to start. So I'm going to go ahead and draw a little isosceles triangle. All right. In an isosceles triangle, how many sides are equal?
All of them.
No.
2 of them.
2 of them. Yeah, all of them would be equilateral. So I'm going to mark these 2 equal. Where is the base in this picture? At the bottom. Good job. Here is one thing that is going to make all of this math easier. Find the base first, always. So I'm going to highlight the base yellow because it is going to be a lot easier to find it if it's bright yellow. So in this triangle, you've got your 2 legs. And since you're drawing the triangle, you can put the base on the bottom. But just know, the base doesn't always mean bottom. It means the side that's not equal to anything. What kind of angles sit on the base? What are they called? What are the names of the angles that sit on the base?
Base angles.
Good job. Base angles. What is the measure of the base angle in this problem?
80.
Good. It's 80. How many times am I going to write 80 on this triangle?
Twice.
Twice. Why do I want to write it twice? There's 2 of them. Where do I put them? Yes, good. On the base. How do we feel about that?
So tired.
I'm tired? Okay, yeah, it was a lot of work we did. Okay, so the base appears twice. How do we solve for the vertex angle, which is that top one? What do?
Add together.
Yep. Add them up, subtract from 180. Exactly what we spent a long time doing. All right, so let's build an equation. I'm going to put an x here. So if I want to build an equation, what 3 angles should I add together?
All 3.
All 3 of them. X plus 80 plus 80 equals 180. All right, what's 80 plus 80? Good. 160. So what is my x value? Good. X is 20. How can we check ourselves to make sure that we did that algebra correctly? Good job. We can always add all the angles up together. So this angle here is 20. So I can do 80 plus 20, and I should get 180 back.
How does 2 work? How does 2 work?
How does 2 work? We'll have to draw a picture in just a second. That's a different problem. So like this example number 1 has 2 parts. One of them, the base angle is 80. So let's try the next one. So on B, your new base angle is 55. So take a second, draw the shape. All right, so on this one, we should get 70. You're adding the 2 base angles together plus the vertex angle to get X. So things you want to remember, problem-solving techniques to make a problem that looks hard, easy. Draw the triangle, highlight the base, because it's a lot easier to do these problems, and then just analyze what it's being asked of you. Okay, what do you have to do, right? So in this next problem,
70.
it's still isosceles triangles. Okay, it's still isosceles triangles.
70.
Okay. Okay. Yes, it is 70. Good job, Gabe. All right, so on this one, shift it over. It says, find the measure of each base angle of an isosceles triangle if the measure of the vertex angle is 1. So the first problem is 40. What kind of shape should I draw? Good. What kind of triangle? Yes, isosceles. So I'm going to make my base here. This is just usually how we all want to draw them. You want it to sit on the base. So I'm going to highlight the bottom. Where does 40 go? Where do I put the 40 in this problem? At the top. This problem tells me that these measures are the vertex angle. How many vertex angles are in each triangle? One of them. So I should only write 40 one time. Now I want to solve the base angles. How many base angles are there? Two. What should I put in the base angle spots? X. Good job. Because I don't know what they are, but I know that they have to be the same. So I'm going to put X in each of those spots because whatever X is, both of those have to equal. So we're building an equation, and this is where vocabulary is really important. If I don't know what a vertex angle is, I don't know how many times to write it. Okay. So how do we set up this equation? We are going to divide in the end, yes.
180 times 40 divided by 2.
Okay, good. Let's start at the very beginning, though.
40 plus x.
Okay, 40 plus x plus another x equals 180. We got to have two of them. So we are going to subtract 40 and divide by 2. But let's take it back a step and write the equation. Because when we get down to the harder problems, like on number 4, we're going to have more to our equation. We can't just subtract. So let's combine those like terms. How do I combine those x's together? What should we get?
X squared.
Not x squared. You're close. That's if I'm multiplying. I'm only adding them. So how many x's do I have? 2. So this is 40 plus 2x equals 180. Now we can do what you guys said, subtract and divide. So you are correct that we are going to subtract 40 and divide by 2. But now we know why we're going to do that. It's because we have to isolate the variable. So when we subtract 40, I get 2x equals 140. So what is my x value?
70.
Yeah, x is 70 because I divide by 2. So when you're doing these problems, just think about what you're solving. There's one vertex angle. There are 2 base angles. That's why we put x twice. So let's solve B. So take a second, draw the picture, write your equation. All right, so to do this problem, we should get 15. Remember, there's 2 base angles, so we've got to write x twice. The reason we write x twice is because we know that both of those base angles are the same, so we use the same variable. Right, they're the same, use the same variable. Okay, so let's talk about problem number 3. Problem number 3 is an ACT question. And that big long test y'all took a couple weeks ago. This is one of a practice ACT question. It's a word problem. And it looks kind of intimidating to me. If I just look at that problem, it doesn't look like it's a nice, neat problem. There's not a lot of numbers, there's a lot of words, and there's equations. But you guys have the tools to solve this problem. We've been doing it. We've already solved it on previous problems. So let's read through it first. It says, if the measure of each base angle of an isosceles triangle is represented by x, then the vertex angle is represented by blank. Now, none of those are number answers. None of them. They're equations or expressions. But let's stop and draw the picture. So what picture should I draw? Okay, what kind of triangle? An isosceles triangle. So let's draw it because it says isosceles triangle. So I draw them sitting on the base. That's pretty much how everybody likes to draw them. So I'm going to mark my legs, highlight the base. So even though this problem has hardly any numbers in it, it can look kind of intimidating. The answers aren't a nice number answer like our other problems. But mathematically, we can draw an isosceles triangle and we can label it. So it says that the measure of each base angle is represented by x. So where should I put x's in my picture? At the bottom, how many? 2 of them. And the reason we did that is because it said the base angle is represented by x. So right here in this problem, it told me what to put here and here. It wants to know which of those expressions would represent the vertex angle. So how many vertex angles do we have in this problem? How many vertex angles are in that picture? We have 2 base angles. How many vertex? One of them. Does it tell me what letter I have to use to represent that angle? Does it say you have to use the letter X or a different letter? No, it doesn't say. It just wants to know an equation. Now, let's pick a letter to represent that top angle. What letter do you want to use? You have 25 options to pick from. You can do this. You have 25 correct answers. A, good job. That's a great letter. We can't choose another letter. All right, so we chose A. Now, why could we not put X up there? Yeah, we already have X. That stands for something else. Now, how do we build the equation if we're working with these angles? Good. There we go. A plus X equals 180. Good job. Now this problem wants us to solve for the vertex angle. It says which of these expressions is represented by the vertex angle. So which variable should we solve for? Which one? X is my base angles. I want my vertex angle. I should solve for A. Because in this problem, Tabby, I'm watching in the chat. I can see you type A. So in this problem, it says the vertex angle is what? This is my vertex angle. I want to solve this equation for A. And you haven't done a problem like this. This is a tricky one. But the math is everything you've done. You've created the triangle before. You've created that equation before. Just now, instead of numbers, we're using letters. So what do we combine here? Can I combine anything? We've got A plus X plus X. What letter can I combine? X. How many X's do we have? 2 of them. Good job. So now I have A, there we go, plus 2X equals 180. Now I still want to solve for A. So how do I get A alone? How do I get A alone? Subtract it. What am I going to subtract? The 2, yeah, I'm going to move the 2X. Can I make minus 2X underneath 180? No, those aren't like terms. So I'm going to put it off to the side. Remember, like we used to do that with slope-intercept form? We couldn't combine. What happens if the 2X is over on the left? What happens here? They cancel. And I'm left with A equals what? 180 what? Good job.
2x.
Yes, 2X. So what answer choice represents the measurement of angle A?
4.
Option 4. So mathematically, this problem might look hard. Hey, it's an intimidating problem. There's no numbers in it. You had to make that equation from scratch. But mathematically, what you've just done is exactly what you just did on the problem before it. So if we're comparing the problem before it, that 150 was basically what angle A was. You've already done this. It just might look a little bit different. Now on Monday, we still have time, don't we?
Monday.
I want to stop here. All right. So